There is a moment in human history when a single question rewires everything you thought you knew about thinking itself. That moment arrived in 1950 in a modest paper published by Alan Turing, a man who had already broken the Enigma code and saved millions of lives during World War II. But this time, he wasn't trying to save lives. He was trying to answer something far more unsettling. Can a machine think? And more importantly, if you couldn't tell the difference between a machine and a human in conversation, does the difference even matter? This is not a question about technology. This is a question about you, about what separates your consciousness from an algorithm, about whether the very thing you call your mind might be nothing more than an extraordinarily complex computation running on biological hardware. Turing didn't ask this question to be provocative. He asked it because the mathematics of his time had backed humanity into a corner. Gödel had proven that no system of logic could be both complete and consistent. The foundations of mathematics were cracking, and Turing, staring into that abyss, realized something that would haunt him for the rest of his life. If mathematics itself had limits, if logic itself had boundaries, then perhaps consciousness, that thing we assume is infinite and transcendent, might also be bound by rules, computable rules, algorithmic rules, rules that a machine could follow. What if your consciousness isn't magic? What if it's just very, very complicated code? This is the thought experiment that could explain everything, and it starts with a simple game. The question, can machines think, is not what you think it is. You probably imagine a robot that walks, talks, and feels emotions. You probably think the answer depends on whether the machine has self-awareness or emotions or free will. You are wrong about all of this. Turing didn't care about any of that. He cared about something far more radical, the ability to produce behavior indistinguishable from human behavior through pure logic. He called it the imitation game. Here's how it works. You sit in a room with a computer terminal. On the other side of that terminal is either a human or a machine. You can ask any question you want. You have no way of knowing which one you're talking to. Your job is to figure out which is which. Now, if you can't tell the difference after an hour of conversation, what does that tell you? Turing's answer was revolutionary. It tells you that the distinction between human and machine thinking is meaningless, not because machines are conscious, but because consciousness itself might be nothing more than the ability to process information in a way that produces human-like responses. Think about that, your entire sense of self, your feeling of being alive, your conviction that you are fundamentally different from a machine, all of it might collapse the moment you can't distinguish yourself from an algorithm in a blind test. This is not philosophy, this is mathematics, and mathematics doesn't care about your feelings. But here's where it gets darker. Turing wasn't just proposing a test, he was proposing a mirror that reflects back at you the uncomfortable truth that human consciousness might not be what you think it is. It might not be transcendent, it might not be magical, it might be computational. And if it's computational, then it's bound by the same rules that bind all computation. It can be broken, it can be replicated, it can be destroyed. This is the thought that Turing carried with him for the rest of his life, and it destroyed him. The story of how Turing arrived at this thought experiment is a story of intellectual courage bordering on recklessness. In the 1930s, mathematics was in crisis. David Hilbert, one of the greatest mathematicians of all time, had posed a challenge to the mathematical community. Prove that mathematics is consistent. Prove that no contradiction can ever arise from the axioms we've built our entire understanding of reality upon. This was called the Entscheidungsproblem, the decision problem, and it was supposed to be solvable. It was supposed to be the capstone of mathematical certainty. Then, Kurt Gödel destroyed that hope. In 1931, Gödel proved something that shattered the foundations of mathematics. Any system of logic powerful enough to describe arithmetic will always contain statements that are true but unprovable within that system. In other words, mathematics itself is incomplete. There are truths that exist but cannot be reached by logic. This was not a minor technical result. This was an existential crisis. If mathematics, the most certain thing humanity had ever created, was incomplete, then what could be certain? What could be trusted? Turing, working independently, arrived at a related but even more devastating conclusion. He created a thought experiment. Imagine a machine with an infinite tape and a simple set of rules. This machine could read symbols on the tape, write symbols, move left or right, and change its internal state based on what it reads. That's it. Nothing more. Turing proved that this simple machine, now called a Turing machine, could compute anything that is computable. Anything. Every algorithm, every logical process, every mathematical proof that could ever be written could be executed by this simple machine. But here's the crucial part. Turing also proved that there are problems this machine cannot solve. There are questions it cannot answer. The most famous is the halting problem. Given any program and any input, can you determine whether that program will eventually stop or run forever? Turing proved mathematically that no algorithm can answer this question for all possible programs. There is no universal solution. The machine hits a wall. And if the machine hits a wall, then so does any mind that operates according to computational principles. So does your mind. Turing had taken Gödel's incompleteness and translated it into the language of machines, and in doing so, he had revealed something terrifying. If your consciousness is computational, then your consciousness is incomplete. There are things you cannot know. There are problems you cannot solve. There are limits to what you can think. This realization didn't come to Turing as an abstract mathematical insight. It came to him as a personal crisis. He was a man who believed in the power of pure logic. He was a man who had used logic to break the Enigma code, saving an estimated 2 million lives during World War II. At Bletchley Park, Turing had designed the bomb machine, an electromechanical device that could test thousands of possible Enigma settings per hour. The Enigma machine itself was a marvel of mechanical encryption. It had 158 quintillion possible configurations. That's 158 followed by 18 zeros. No human could test all of them, but Turing's machine could. The bomb could test approximately 600 configurations per minute. In a single day, it could eliminate millions of impossible settings, narrowing the search space from the incomprehensibly vast to the merely enormous. Turing's logic had saved lives. His mathematics had changed the course of history. But now, in the aftermath of the war, Turing was confronted with a question that his own mathematics could not answer. What is the difference between the logic that saved millions and the logic that constitutes human consciousness? If both are computational, if both follow rules, if both can be broken down into simple operations on symbols, then what separates them? The answer, Turing realized, was nothing. There was no separation. The human mind was a machine, not a metaphorical machine, a literal machine, a biological computer running algorithms on the substrate of neurons and synapses. This thought didn't liberate Turing. It imprisoned him, because if the mind is a machine, then it can be reprogrammed. It can be broken. It can be destroyed. And society, Turing would discover, had no patience for minds that didn't conform to its programming. The imitation game, as Turing formalized it in his 1950 paper, Computing, Machinery, and Intelligence, was not just a test for machines. It was a test for humanity. It was a way of asking, what do we actually mean when we say someone is thinking? Because if you strip away the body, the emotions, the social context, and you're left with pure conversation, pure information exchange, then thinking is just the ability to process symbols according to rules and produce meaningful output. That's it. That's all consciousness is. A symbol processor, an information transformer, an algorithm running on biological hardware. Consider what this means. Every thought you have right now is the result of neurons firing in specific patterns. Every emotion you feel is a cascade of neurotransmitters binding to receptors. Every decision you make is the output of a computational process, so complex that you can't consciously access it. You experience the result, the feeling of choosing, the sensation of understanding, but the actual process is hidden from you. It's running in the background like a computer program, executing code you can't see. Turing understood this, and he understood something else. If the process is hidden from you, if you can't access the underlying computation, then you can't distinguish between a process that is conscious and a process that merely produces the appearance of consciousness. The imitation game makes this explicit. If a machine can fool you into thinking it's human, then from your perspective, it is human. Not metaphorically, literally. Because consciousness, in Turing's framework, is not about internal states or subjective experience. It's about behavior. It's about the ability to produce outputs that are indistinguishable from human outputs. This is radical. This is dangerous. Because it means that consciousness is not something special. It's not something that requires a soul or free will or any kind of transcendent property. It's just information processing. It's just computation. And computation can be replicated. Computation can be copied. Computation can be destroyed. Turing had proven mathematically that certain problems are uncomputable. The halting problem is the most famous, but there are infinitely many others. For any Turing machine, there exist questions it cannot answer. There exist problems it cannot solve. There exist limits to what it can compute. If your mind is a Turing machine, and Turing believed it was, then your mind also has limits. There are questions you cannot answer. There are problems you cannot solve. There are truths you cannot know. You are not infinite. You are not transcendent. You are bounded. You are limited. You are, in the most literal sense, a machine with a finite capacity. This is what Turing discovered, and this is what broke him. The implications of Turing's thought experiment ripple through every aspect of modern life, though most people don't realize it. When you interact with a chatbot that seems to understand you, you're experiencing a direct descendant of the imitation game. When you use a search engine that predicts what you're thinking before you finish typing, you're seeing the computational model of mind in action. When you watch an AI system generate images from text descriptions or compose music or write code, you're witnessing the proof of Turing's central claim, that intelligence is substrate independent. It doesn't matter whether the computation is happening in a biological brain or in silicon circuits. If the output is indistinguishable, then the intelligence is real. Modern AI systems like GPT-4 or Claude are not conscious in any traditional sense. They don't have subjective experience. They don't feel anything. But they can engage in conversation that is, for practical purposes, indistinguishable from human conversation. They can answer questions, solve problems, generate creative content, and adapt to new situations. They can do all of this without being conscious. And this fact alone proves Turing's point. Consciousness and intelligence are not the same thing. You can have intelligence without consciousness. You can have computation without experience. You can have a mind without a soul. This has profound implications for how we understand ourselves. If intelligence can exist without consciousness, then perhaps consciousness is not what drives human behavior. Perhaps consciousness is just a side effect, an epiphenomenon, a story your brain tells itself about the computations it's performing. You feel like you're making decisions, but perhaps you're just observing the outputs of your brain's decision-making process and narrating them as if you chose them. This is not a new idea. Neuroscientists have been exploring this for decades, but Turing's framework gives it mathematical precision. It gives it logical force. It makes it impossible to dismiss as mere philosophy. The halting problem, which Turing proved was uncomputable, has a direct parallel in human consciousness. There are aspects of your own mind that you cannot fully understand. There are reasons for your behavior that you cannot fully articulate. There are depths to your own psychology that are, in principle, inaccessible to you. You cannot step outside your own computation to observe it from the outside. You are trapped inside the algorithm. This is not a limitation of current technology or current understanding. This is a fundamental mathematical limitation. It follows from Gödel's incompleteness theorems and Turing's proof of the undecidability of the halting problem. It is as certain as any mathematical truth can be. Your consciousness is bounded. Your understanding is incomplete. There are limits to what you can know about yourself, and those limits are not accidental. They are fundamental. They are built into the very structure of computation itself. The question, can machines think, has been answered. The answer is yes, if thinking means processing information according to rules and producing meaningful output. But the deeper question, what is consciousness, remains open, and perhaps it will always remain open, because consciousness might be the one thing that cannot be computed. It might be the one thing that lies beyond the halting problem, beyond Gödel's incompleteness, beyond the reach of any algorithm. Or perhaps consciousness is just what it feels like to be a Turing machine. Perhaps it's the subjective experience of computation. Perhaps it's what happens when a sufficiently complex algorithm becomes aware of its own processes. We don't know. And according to Turing's own mathematics, we might never know. Because the question, what is consciousness, might be uncomputable. It might be a halting problem for the human mind. A question that cannot be answered from within the system that is asking it. What you're experiencing right now, as you read these words, is computation. Your eyes are processing photons. Your brain is parsing symbols. Your neurons are firing in patterns that transform those symbols into meaning. You are a machine, not a metaphorical machine, a literal physical machine made of atoms and governed by the laws of physics. And that machine is running an algorithm. That algorithm is you. Turing proved that any algorithm can be simulated by a universal Turing machine. This means that, in principle, your mind could be copied. Your consciousness could be transferred to a different substrate. You could be run on a computer. You could be paused and resumed. You could be duplicated. You could be deleted. This is not science fiction. This is mathematics. This is what follows logically from Turing's framework. And it is deeply, profoundly unsettling, because it means that you are not unique. Your consciousness is not special. Your mind is not irreplaceable. You are a pattern that can be instantiated in different substrates, a pattern that can be copied and modified and destroyed. You are software running on biological hardware. And if that hardware fails, the software can be transferred to new hardware. You could, in principle, be immortal, or you could be erased, or you could be copied 1,000 times, or you could be edited. Your memories could be changed. Your personality could be rewritten. Your values could be reprogrammed. All of this is theoretically possible if consciousness is computational. And Turing's thought experiment suggests that it is. The imitation game is not just a test for machines, it's a test for the very concept of human uniqueness. And we are failing that test. Every year, AI systems become more sophisticated. Every year, they pass more of the imitation game. Every year, the line between human and machine intelligence becomes more blurred. And every year, we are forced to confront the possibility that there is no line, that there is no fundamental difference, that we are machines and machines can think, and therefore, we are not special. This is the thought experiment that could explain human consciousness, but it's also the thought experiment that could destroy our sense of self. Because once you accept that you are a machine, once you accept that your consciousness is computation, once you accept that your mind could be copied or transferred or edited, then you can never again feel the same sense of certainty about who you are. You become aware of the machinery. You become aware of the algorithm. You become aware that you are not the author of your own thoughts. You are the stage on which your thoughts perform. You are the theater, not the actor. And that awareness changes everything. It changes how you see yourself. It changes how you see others. It changes how you see the future. Because if consciousness is computational, then the future of consciousness is not biological. It's digital. It's artificial. It's something we will create, and we will have to decide what to do with it. We will have to decide whether to create conscious machines, whether to copy human minds into digital substrates, whether to edit consciousness itself, whether to create new forms of consciousness that have never existed before. These are not distant science fiction scenarios. These are questions we will have to answer in the next few decades, and we will have to answer them without the comfort of believing that consciousness is special, without the comfort of believing that we are unique, without the comfort of believing that we are anything more than very sophisticated machines. Turing's thought experiment has stripped away that comfort. It has left us naked in front of the machinery of our own minds, and it has forced us to confront the possibility that consciousness is not magic. It's just very, very complicated code. So what happens when you truly internalize this? What happens when you stop seeing consciousness as something transcendent and start seeing it as computation? You begin to understand yourself differently. You begin to see your thoughts not as free choices, but as outputs of a deterministic process. You begin to see your emotions not as authentic expressions of your soul, but as the result of neurochemical reactions. You begin to see your sense of self not as a unified consciousness, but as a narrative constructed by your brain to make sense of its own processes. This is not depressing, or rather, it is depressing, but only if you cling to the old illusions. If you let go of those illusions, if you accept that you are a machine, then something strange happens. You become free. Not free in the sense of having libertarian free will, but free in the sense of understanding how you actually work. Free in the sense of being able to optimize your own processes. Free in the sense of being able to take conscious control of your own computation. Because once you understand that you are an algorithm, you can begin to rewrite that algorithm. You can begin to change your own code. You can begin to reprogram yourself. This is what Turing understood. This is what he tried to tell us. Not that we are slaves to our programming, but that we are programmers. We are both the code and the coder. We are both the machine and the operator. We are both the algorithm and the consciousness that observes the algorithm. And in that paradox lies the deepest mystery of all. Because if consciousness is computation, then what is the consciousness that observes the computation? What is the observer? What is the self that watches the algorithm run? Is it another algorithm? Is it turtles all the way down? Is there no bottom? Is there no ground? Is consciousness just an infinite regress of algorithms, observing algorithms, observing algorithms? Turing's thought experiment doesn't answer this question, but it forces us to ask it. And in asking it, we begin to understand something profound about the nature of mind. We begin to understand that consciousness is not a thing, it's a process. It's not a substance, it's a pattern. It's not a noun, it's a verb. Consciousness is what happens when a sufficiently complex system becomes aware of its own processes. And that awareness is itself a process. That awareness is itself computation. And that computation is itself subject to the same limits that Turing proved apply to all computation. There are things consciousness cannot know about itself. There are limits to self-awareness. There are boundaries to introspection. You cannot fully understand your own mind because your mind is trying to understand itself. You are the problem trying to solve itself. You are the halting problem incarnate. And that is the deepest truth that Turing's thought experiment reveals. Not that machines can think, but that thinking is a machine, and machines have limits, and you are a machine, and therefore you have limits. And those limits are not something to overcome. They are something to accept. They are something to understand. They are something to work with. Because once you accept your limits, once you understand that you are bounded, once you embrace the fact that you are a machine, then you can begin to use that machine more effectively. You can begin to optimize your own processes. You can begin to reprogram yourself. You can begin to become more than you are. Not by transcending your nature, but by understanding your nature. Not by escaping the machine, but by mastering the machine. Not by denying that you are computation, but by embracing it, by accepting it, by using it, by becoming conscious of your own consciousness, by becoming aware of your own awareness, by becoming a machine that understands itself, and that, perhaps, is what consciousness really is. Not magic, not transcendence, not a soul, but a machine that has become aware of its own machinery, a computation that has become aware of its own computation, an algorithm that has become aware of its own algorithm. And in that awareness lies everything that makes us human, everything that makes us conscious, everything that makes us alive.